Okay, so let's solve this question. The question states that consider the following recurrence relation, right? This is a recurrence relation, right? This kind of recurrence relation is extensively used in the analysis of algorithms, right? And you must have faced this at some point, right? I will give you a small reminder of what exactly is Tn so that you have better can understand the solution that I'm giving better, right? And the question basically is a MCQ type question because there is one is present over here, so only one of the options is going to be correct, and after that it's just basically one option has to be correct that we have to find, right? Now to understand Tn, right? Tn is basically nothing but your running time, right? Tn is basically your running time, right? Suppose that a particular computer CPU has a definite number of fundamental instructions and all of those instructions take equal amount of time. Then for n input of the input that is provided into the algorithm, this n basically represents the input size that is fed into your algo, right? Then the amount of time that it's going to take is going to be proportional to, right? This is the time. So let's take a different symbol over here. Let's take tau. Tau is proportional to your Tn, right? And Tn basically represents the total number of instructions, right? And we call this running time, right? You basically basic flow you must be able to understand that n is basically the input. The more the input, the more the time CPU time is going to be used, right? And we are basically measuring the amount of CPU time by the number of fundamental instructions that the CPU is executing, and the assumption is that the fundamental instructions consume equal amount of time, more or less, right? That is basically the whole of the assumption regarding Tn, the running time which we are basically using over here, and that is why it expresses algorithmic time, right? Because your computers and CPUs differ, but the number of instructions that are being processed is going to be constant, irrespective of the CPU that is being fed with the algo, right? With the input. That is why we are using Tn over here, right? Once that part is very well revised on your part, let's attack this question, right? It's a pure deduction based question that you must basically apply deduction to this and get to the expansion of Tn in terms which does not include another variant of Tn on the definitional part on the right hand side. That is what we have to basically find, and for that we are only given the information that T0 is equals to 1, right? This is the basic understanding of the question, but understanding the question is half the answer, right? So obviously after all this you must be able to understand that we basically to get any meaningful information out of this, we must express Tn in terms of T0, otherwise you're not going to get any solution out of this, right? That basic step that you must have to do, right? This is something that you have to do. Now let's try to analyze this and try to see is there any way to basically shift this in terms of shift the right hand side of this closer to T0. Can we do that? Let's see. Okay, so I've written this one more time over here. Now let's attack it, right? So if this is true and n is basically any positive integer, right? So we can also take n minus 1 and feed it inside of Tn over here, and that the equation that we are going to derive is also going to be true. Just the n is going to basically change from this to this. I hope that is that actually correct, because n is greater than 0, it must feed equal to 0, and n minus 1 is equals to 0, so n is equals to 1, right? So for n equals to 1, n minus 1 is going to become 0, right? So that's why n must be greater than 1, right? So that assumption is correct. So I can take n minus 1 over here and basically get the variant of it like this, right? Plus n minus 1 to n minus 1, right? With this assumption. Very well understood, right? And because n can be anything, any natural number greater than 1. Likewise, we can also write it for Tn minus 2 is equals to 2 Tn minus 3 plus n minus 2 to n minus 2 for n is greater than 2, right? I'm basically substituting n minus 1 into this n and getting these equations, right? Pretty straightforward. I don't think there is any complexity over here. This thing you must be able to follow now, otherwise you are not studying 9th and 10th. This is 9th and 10th level basically analysis, right? Once I have the value of T1 and T1 and T2, right, I can take this value of T1 and apply it over here, right? This is Tn minus 1 only. I can substitute the value over here and with that the whole right hand side is going to become 1 closer to T0, right? This is very straightforward actually. Let's do that. So Tn is going to become 2 times Tn minus 2 n minus 2 plus n minus 1 to n minus 1. This is basically this part has been replaced with this whole part which I got, and then this part is going to remain unchanged, so I am basically adding it over here, 2n, right? Pretty straightforward, pretty simple, right? Now just simplify it, because this is a bit of intermediate state. You must simplify the whole terms in every stages, because that way you are better able to understand the whole thing, right? Too much information is never good for us. So let's simplify this. Multiply this 2 over here, this 2 over here, and expand this part, and then see if you can simplify it with in terms of this. Let's do that. You're going to see, you're going to find out. So 2 raised to the power of 2 Tn minus 2 plus 2, this 2 when multiplied over here, this minus 1 is going to vanish, right? Okay, so 2n n minus 1 plus n 2n. Let's take this 2n common, right? Pretty straightforward. Let's do that. 2 square T n minus 2 plus 2n n, no, not 2n, because this plus this is going to give me 2n, right? 2n minus 1, right? This is the simplified format for Tn. Mind you, now in the original equation the Tn was in terms of Tn minus 1, now Tn is in terms of Tn minus 2, right? Now replace n minus 2 with n minus 2's right hand side, which we had basically found over here. Why am I doing all this? Why am I following along this kind of expansion? Because you must be able to know that these natural numbers, if we replace like this, I can basically replace it till infinity, because n is a natural number, it is a variable. I can go on replacing like this till infinity, right? There is no restriction on that. I understand that. But the thing about the thing that I always say is, we as humans can comprehend patterns, right? And once we have done certain steps over here, the pattern is going to manifest itself, and we, the ones who have actually followed along the whole story, are going to be able to interpret the underlying narrative, right? Just the way you are able to understand the intentions and motives of a hero in a movie. You don't, the movie never states the intentions directly, but you as a person who has followed along the whole story, along the narratives, the inductions and the flows, are able to perceive the patterns of what exactly is happening, right? The same thing is going to happen over here also. When I'm going to do it over here, let's just replace this Tn minus 2 with its right hand side, right over here. We get what? This thing is going to become 2 square 2Tn minus 3 plus n minus 2 whole 2n minus 2 plus 2n minus 1, right? This part is basically coming from this part, right? Very straightforward, not very complex. Now let's simplify this thing, right? If I were to multiply this over here, this n minus 2 is going to vanish, right? So let's do that, and this multiply directly, this when multiply directly with this is going to give me 2 cube T n minus 3 plus 2n n minus 2 plus 2n minus 1, right? Once we have this, we can take this and this common to simplify it further. What do we get? 2 cube Tn minus 3 plus 2n 3n minus 1 plus 2, right? This 1 plus 2 is basically coming from this part, minus 1 over here and minus 2 over here. Taken minus outside, we're getting this thing, right? Once I've done all this now, and this is expressed in terms of Tn, right? All the patterns which are basically happening are laid out, because I simplified at every single term and take it out in a very consistent manner, right? The next term, that is this n minus 2, the next, if I were to replace this with n minus 4, then this minus 2 is going to be replaced with minus 3, and this summation is going to go till 3. Likewise, this 3n is going to be added with one more n, and this is going to become 4n, right? So this is a direct incremental pattern that we are able to observe, right? As is present over here, this is minus 3 and this is 3 cube, right? Another, if I were to replace it over here, another 2 is going to come, just as another 2 came over here, right? So this is going to become T raised to the power 4. So this is a very simple, convenient pattern that we are able to observe. Now let's generalize it, right? So let's replace this 3 with a b, and we can generalize the pattern because we have observed it, right? If you have observed a pattern, try to generalize it, and with that then use that generalization to get an answer which is get it into a format that you want, right? That is basically being practical, being very practical, right? N minus b plus 2n. Mind you, this is n is not changed. This 3 over here is b, not n, so this is going to stay as same, and this is bn minus, and this is c over here. This is not adding up till b, because if it were to be adding up till b, then there must have been plus 3 also. So it is adding up till b minus 1, right? This summation is from 1 plus 2 plus 3 dot dot b minus 1, right? This is the summation that we are getting, right? And what does this kind of summation basically evaluates to? The addition of natural numbers is given by the equation n plus 1 by 2. This is the formula that gives the summation of first n positive natural numbers. We have to basically substitute this n with b minus 1 because it is present over here. What do we get? We get b minus 1 times b by 2, right? B minus 1 times b by 2. This is something we're going to get over here. Now let me be very clear. At the starting of the question, we came to this understanding that we have to get Tn in terms of T0, because T0 is the only value in the whole of recursion that we know of, right? So T0 is something that we have to get to. So if I were to take this b and make it equal to n, this n minus n is going to become what? 0, right? So let's take b as n and simplify from there, right? What do I get? Tn is equals to your 2 raised to the power of n t0 plus 2n n square minus, and this part basically, and I'm replacing b with n, so this is going to become n minus 1 times n by 2, right? This is basically the simplification that we got, right? This is the basic simplification that we got. Now once we have that, let's basically simplify and get the answer, because now this t0 is given as equal to 1 at the starting, right? So we can directly replace it over there, and if I were to do it like that, I don't have another t on the right hand side, right? So basically got what I wanted. Now we have to simplify it, right? So let's do that. So what do I get? 2 raised to the power of n. If I were to take this common, I will get 1 plus n square minus n square minus 1 by 2, and this is like this, right? Bracket I'm not opening right now, so this is what it is going to come out to be. Now let's simplify it. No, not really. This is a mistake that I made over here. This is when this expands, this becomes n square, this becomes n, right? So this will be n, right? Not your, let me take it, n minus n, right? N square minus n by 2 whole bracket close. This is what I'm going to end up with, right? Now let's simplify it further so that we can have a very good expressive expression, right? 1 plus n square minus n square by 2 plus n by 2, right? Very straightforward. This thing becomes what? When I minus n square minus n square by 2, so if I can remove this over here and basically divide this by 2, very straightforward, right? I get this expression, right? Now let's look at the options, because I've simplified it till a very good level. Now even if I were to multiply it on the and open up this bracket, it's not going to simplify it further, right? It is very simple. It is already very simplified. So let's look at the options. The options basically give us the expression. They want the expression in theta notation, right? Theta notations. Now theta notations have a property. You must have studied this. If you have forgotten, please do look up any video on this on YouTube. You will be able to understand this. Basically, any expression, for example, if I were to take theta expression and n square plus n plus 1, these don't expand at the rate of your n square. So these can be removed as a simplification inside of theta notation, right? If I were to take 3 over here, this coefficient does not really matter when expansion is concerned, right? Theta notation is basically primarily concerned with expansion rate, right? So this can also be removed, right? So this is the kind of simplification which is allowed inside of theta notation. So I'm basically going to make use of that. So because theta notation is an approximation, so I'm going to use an approximation symbol over here, right? Theta notation 2n, basically I'm expanding this out now, right? 2n plus 2n n square by 2 plus 2n n by 2, right? So now let's look at this. So this expression is going to expand at much faster rate because this is an exponential function and this is a quadratic function, both multiplied. This is an exponential function and this is a linear function. So this is going to expand at much faster rate compared to this, and both of these are going to expand at much faster rate compared to this, right? So this, what does this mean? This means that we can directly, as an approximation, ignore these parts, right? And this is nothing but a coefficient that is being multiplied, so we can ignore this part also. What am I left with? I'm left with this thing, 2n n square, right? This is your Tn. Sorry, I used the direct symbol equal to, but this is the equal to symbol is also used because in the end of the day, this equal to over here, in the exact definition of theta notations, these are basically sets, right? So this equal to notation is assumed. This equal to notation over here now is basically assuming as Tn is belonging to the category of theta being a set. This is a pure mathematics definitions being present. This is what this notation basically means. This is what they are using in the basically options that are present, right? If you don't know this part, then your concept regarding this is not very clear, and you must go and watch some videos on this because this is very basics of the basics of computer science, right? You must know this, right? Not for GATE point of view, in general also you must know this, because if you're a computer science graduate, you must know this, right? So let's see if there is any option which gives Tn is equals to theta n square, so 2n, right? So as is very evident, the first option is going to be your answer, and it was 1 mark question, but for a 1 mark question it was a difficult question. It is going to take an enormous amount of time, and if you do a silly mistake, it is going to lead to negative marking, right? But obviously practice and practice is a must thing, but you must solve this question by yourself and not rely on other people's solution, because if you're not tried to solve this question by yourself and directly watch the video on its solution, that is not good, because that is going to give you a false sense of learning that is not very productive, right? Even if you try to solve it by yourself and get to a wrong answer and then you see a solution, that is much better, because your mind is going to become receptive to the new information that is presented in the video or anything, right? So please try to solve it by yourself. That is a humble request from my end. And that if you had learned something new or you like the video, like and subscribe, and I will see you in the next one.